Hi everyone, today we are gonna know about mesh analysis. The basic concept of mesh analysis is KVL plus Ohm's law. We use KVL for solving circuits and we use Ohm's law internally. So let us consider a circuit over here. Let this be the circuit and we're gonna analyze mesh analysis. We're gonna apply mesh analysis to this circuit. Here we have a current source, resistor, capacitor, inductor, resistor, voltage source and a resistor again. So how we write KVL? We have three particular rules for writing KVL. The first thing is we have to form or identify the meshes. So we identified three meshes over here. This is I1, this is I2, this is I3. And now let us write the equations for particular meshes. So we identified the meshes that should be in clockwise direction only. Next, applying the KVL. Let us consider this equation first. We have inductor, resistor, voltage source, a resistor again. L, R, 2, R, 3, V of t. So, we are considering flow of current in this direction. This is mesh 3. Flow of current in this direction. And for the inductor, the influence of two meshes will be there. So here another continuation will be there, no? So from there we have the current I2. Here we had mesh 2. Here we have mesh 2. So influence of this current will be there on inductor. So we have to show this in the equation. So I2 and I3 will be there on inductor. And this is positive to negative, positive to negative, positive to negative, and this is positive and this is negative. In this way we have to consider. So how will write the equation? How will write the equation is this means third minus V of t minus V of VR3. VR3 is what? Voltage in R3. I3 into R3 minus, because of the voltage drop, this is L into d by dt of I3 minus I2. I3 minus I2. I3 minus I2. Again we have R, no? That is minus R2 into I3 is equals to 0. Another consideration here, in mesh 3, I3 current is greater than other two currents. So what we have to write? I3 is greater than I2. I3 is greater than I1. This is the condition. So we are getting this type of relationship. Okay, this is the mesh equation of third mesh. Next, let us move for mesh 2. Sorry for the mess. Hope you guys are comfortable. So in the mesh 2, what we have a resistor, a capacitor, an inductor, we have a resistor, a capacitor, an inductor. So this is L, C, and this is R, and we have a continuation here, don't ever forget it. And this is mesh 2. Here also we have. So the current flowing through it is I2, right? So positive to negative, positive to negative, positive to negative. Okay, now here the current is in this direction. I'll show you with another pen so that you guys will be comfortable. So clockwise, right? This is I3 and this is clockwise I1. Okay, another condition, I2 is, so we are considering mesh 2. So here only this current will be greater. So I2 is greater than I3 or I2 is greater than I1. This both conditions should be there for solving this mesh equation. So let us solve the equation. So we have minus VD, voltage across the inductor, that is L into di of I2 minus I3 by dt, minus resistor R1 into, this is R1, resistor R1 into I2 minus I1. This is attached to these two meshes, minus 1 by C integral minus infinity to t I2 of dt, I2 dt. This is the mesh equation for mesh 2. This is the Ohm's law. Here this relationship is Ohm's law. Here also we have Ohm's law. Here this is Ohm's law. And voltage in a closed circuit is always equals to 0. This is mesh 2 and this is completed, and this is equivalent to this. Another mesh. Now let's consider mesh 3. Okay, What is mesh 3? In mesh 3 we have a current source and a resistor. That's it. This is I of t and this is R1. I1. Mesh 3, right? We have here I2. Do you know one thing? The voltage across any two parallel elements will be 0. So, the voltage of source V1 will take minus this voltage with resistor is same. This both are same, means this is equals to 0. So we don't have any particular equation for this mesh. So here only verification can be done. KVL verification is done. There is no particular equation, mesh equation for this type of circuits. The elements which are connected in parallel. The voltage here will be voltage here. The voltage in this element will be same in this element. So we have only chance of verifying KVL. That's it. So by this way we can solve any other circuits using mesh analysis. And if you are perfect at this, you can solve any kind of tough circuits. So hope you enjoyed this session. Bye bye. Have a nice time. Bye.